Today we'll discuss some important points to remember while solving the problems related to determinant. Usually in the exam you'll be given with the determinant rather than giving numbers as the elements. The elements will be say A, B, C or X, Y, Z or something like that, and you'll be asked to simplify the determinant or express it in terms of A, B, C in a simplified form, or maybe it will be a proof that question with an RHS given in a particular form of ABC. So something like that. In such cases, it is always important to know what is our final aim or what are the usual procedures that we adopt. So here we are going to give an idea about such procedures. So in most of the questions, our aim will be to simplify the determinant with maximum number of zeros in any of the row or column. You will have to simplify such a way that you are having many zeros or maximum number of zeros in any of the row or column, so that the expression will be in simplified form. And for that, what you have to do, you will have to do some elemental row or column transformation. Say for example, R1 is given as R1 plus R2 plus R3, or say C3 is given as C3 minus C2 or something like that. So such elemental transformations will allow you to take a common factor out from the determinant. Okay, we'll do another video with such problems. Now I'll just explain the procedure. Okay, then after taking the common factor out, what do? We'll be left with many ones. We'll have any one of the row or column with maximum number of ones. Now we have to subtract those rows or columns and thereby obtain maximum number of zeros, and then you can express the determinant in terms of A, B and C. Okay, in some questions, in some tricky questions, you might have to apply some other procedure. This is one such example. In some questions, maybe you'll have to multiply the determinant with A, B, C in such a way that A is multiplied to row 1 and B is multiplied to row 2, C to row 3. You do such multiplications first and then you will take the common factor from columns. Okay, you're multiplying that to particular columns respectively, and you might take the common factor from rows. That will express that determinant in a different form, which will be easy for simplification. So this is another method that might have to be applied for simplification. Okay. So in the first method, and usually in simple questions, your aim will be to obtain maximum number of zeros in any row or column. That is done by simple transformations and then taking the common factor out from the determinant and then obtaining zeros and simplifying the expression. In some tricky questions, you might have to multiply rows with a particular element and take that element common from a column. Okay. Now here we'll discuss some of the usual mistakes that students often make in the exam. Okay, see, first thing most students do is that whenever they do a row or column switching in position, that is when R1 is switched to R3 or a column is switched in position, they forget to put the negative sign. Always remember, whenever two rows or two columns are swapped in position, whenever two parallel lines in a determinant switch their position, a negative sign is introduced. So whenever you switch the position, never forget to put the negative sign. That is the first mistake that is often seen in the examination. Then what is second? In some problems, as I said before, you might have to multiply with a scalar throughout the row or throughout a column. For example, see, here A is multiplied to the first row and B is multiplied to the second row, C is multiplied to the third row. In some questions, we do such kind of multiplications to take some common factors from columns. We do the multiplication along a row and we take common factors from a row. There are some questions in which this technique helps. So in such questions, never forget to put 1 by ABC in front, because you know that according to the property, whenever a scalar is multiplied to the determinant row or column, that determinant itself will be multiplied, that value will also be getting multiplied with that value. So therefore, to nullify that, you have to multiply it with 1 by that term. So here we are multiplying A to row 1, B to row 2 and C to row 3, and therefore we are multiplying that with 1 by A, B and C. We have to divide with the same term to nullify the effect. This is also a usual mistake seen in the exam. Never forget to divide with the scalar that you are multiplying. Okay, this is not the case when you're doing a row addition or row subtraction. Other than that, without doing any addition or subtraction, you are simply multiplying an element to a row. In such case only this is applicable. In cases like R1 becomes R1 plus 3 R2 or something like that, in those cases you don't have to divide. That is row addition. In those cases the determinant value is not changed though, so you don't have to divide with that element. But if you're simply multiplying an element to a row without any addition or subtraction between the rows, then you will have to divide with the same element. This is another important point. Now the third mistake that is often seen is, whenever you are taking a common factor from a determinant, always keep in mind you have to take from each row or each column. Okay, for example, in this determinant there is k common in all the row and all the columns. In that case you will have to take k common from first row, then from second row, then from third row, and thereby you will have 3 k's in common, that is k3 into determinant. Don't write k into delta, that is wrong. You have to take 3 k's common from this determinant. So it will be k cube into delta. So we'll do a following video with these important techniques applied. We'll see.